This video will be a brief introduction to free fall motion. Free fall occurs when an object is accelerating due to gravity. So you can imagine we have a ball and it's falling through the air. And we know objects speed up as they're falling down. What's causing this ball to speed up? Gravity. Gravity is pushing down on it. So we would say that the ball is accelerating due to gravity. And if we forget about air resistance, then the only force acting on this ball is gravity, so it is falling with free fall motion. Here's another example. Imagine we have a person and they throw a ball up. We know when that ball gets thrown up, it will slow down until it reaches a maximum height, and then it will fall back down to the ground. The second that ball leaves the person's hand, it is in free fall motion, and that's because it's accelerating due to gravity. And just to make it clear, an object can only be in free fall motion if the only force acting on it is gravity. So the object can't have an engine or an external force that is causing it to accelerate. Only gravity can be acting on the object, and only gravity can be causing it to accelerate. If both of those conditions are true, then the object is moving with free fall motion. And when you use your kinematic equations to solve free fall motion questions, the acceleration you use will be the acceleration due to gravity, which is always equal to negative 9.8 meters per second squared. So just to make this clear, the acceleration value that you use when an object is moving with free fall motion is always A is equal to negative 9.8 meters per second squared. Let's do an example to make this clear. Here we have a ball which is dropped from the top of a building. If it hits the ground with a velocity of negative 40 meters per second, how tall is the building? So I know this is a free fall motion question because this ball is accelerating as it falls down due to gravity, and gravity is the only force acting on the ball. Now that we know it's free fall motion, let's jump into what was given. We know the initial velocity is 0 meters per second because the ball was just dropped. It wasn't thrown down. We also were told that the final velocity is negative 40 meters per second. The negative comes from the fact that the ball is falling down, and velocity vectors that are pointing down are negative. And because this is free fall motion, we also know that the acceleration is equal to negative 9.8 meters per second squared. And what we're solving for is delta y, the change in position, which would be how tall the building is. It's important to note that we're missing the delta t variable, which means the best kinematic equation to use would be the Vf squared is equal to Vi squared plus 2a delta y equation. With that, all we have to do is rearrange our equation for delta y and then plug in our values. Once we solve for delta y, we can see that the building is 81.6 meters tall. And that's the end of our free fall motion lesson. If you want more practice, check out the other free fall motion questions that I've posted.